All right, so it says in triangle VYZ, ST and U are midpoints. It says prove that triangle YST, which is that top triangle, is congruent to triangle TUZ, which is the bottom right triangle, which is congruent then to triangle SVU, which is the bottom left triangle, which it should then be congruent to what they want us to fill in, which will end up being SUT, which is that middle triangle. Okay. Because this bigger triangle is larger in scale than this one here, or I guess the bigger one here is bigger than any one of these smaller ones. Does that kind of make sense?
Yeah.
So it can't be congruent that way. So look at this and fill in the blank, obviously. So we're looking for triangle. Gave us two options here, UTS or VYZ. So VYZ is that bigger one. UTS is that middle one. That's the one we want to check. Okay, so that's what we're getting at, and now we'll go through the reasons. It says VYZ in that triangle, ST and U are midpoints, so that was provided, that's given. And that would then provide these congruencies that exist. Okay. Now, the fact that 1/2 VZ is equal to VU, which is equal to UZ. Okay, so 1/2 VZ. So VZ is this bottom one, right? Okay. If we think about mid-segments, half of VZ, or sorry, not mid-segments, midpoints. Half of VZ should be the same thing as VU, right? And half of VZ should be UZ. So what they're getting at there is that ultimately VU is congruent to UZ. That's what's allowing us to make these marks in here, okay? It's kind of a weird way of them showing it, but they're ultimately walking you through the fact that these are midpoints. So by the definition of midpoints, we end up getting these congruency or equality statements. Does that kind of make sense? Okay. Maybe a different way of dealing with it than what we've done in the past, but that's what they're getting at. Okay. Now, this third portion, they're saying ST, which now it's the midsegment. ST is the midsegment. That is half of V to Z. Okay. They're then saying that TU, which is this midsegment, is half of YV. And then they're saying SU, midsegment, is half T to Z. Or sorry, Y to Z. Okay? And that's the idea of what we've talked about with midsegments. It's not the definition of a midsegment. The definition of a midsegment says that it's the segment that connects two midpoints of a triangle. It's the triangle midsegment theorem, okay, which states that the midsegment is parallel and half of the third side. Okay, so now we've got a lot of stuff going on here. It says ST is equal to VU is equal to UZ. Looking at that statement right there, how can I make that statement? We'll go back up to what we've already stated. If I've got right here, they say VU is equal to UZ, right? And down here, that's pretty much, I have 2/3 of that statement, correct?
Yeah.
Okay. Now, how do I get this 1/2 VZ to change into ST? Right there. Does that make sense? Okay, so step 4 is saying the exact same thing that step 2 said, but wherever I see 1/2 VZ, we're replacing it with ST. Okay. Same idea then when I get to this portion, TU, VS, and SY. If I look up here, we have VS and SY. Okay. But instead of TU, we have 1/2 VY. Well, how do I get 1/2 VY to become TU? It's in that equation right there. Does that make sense, everyone? You see that? And then you're going to do the same thing then with SU, YT, and TZ. So if I'm replacing from step 2, I replace that with what it was equal to, I replace that with what it was equal to, and I replace that with what it's equal to. What is that process?
Substitution.
Substitution. Okay. And substitution does not exist in this one, so what is my option? It's primary transit. Okay. I don't necessarily like how they're using the transit property maybe here, but they're saying that it's this idea here. If I've got ST is equal to 1/2 VZ, and then I got 1/2 VZ is equal to, let's just write VU, and then UZ. Okay, those are two statements. They're saying this is your A object, this is your B object, this is still B, right? And then this stuff here would be your C stuff. It's kind of weird, different way that we've seen transit property being used. But if A is equal to B, and B is equal to this stuff here, a C term, then can we make the conclusion that A is equal to C?
Yeah.
Which is ST then equal to BU equal to UZ. So it is a transitive property. I think substitution is probably a little bit of a better option there, but I think we can deal with that. So the next part says 4 and 5, those two statements are pretty much identical, right? We go from distances being equal to segments being congruent. So that provides us the definition of congruence, so it's provided by the definition of congruence. And the last part says all these triangles are congruent, and we talked about, why are all these triangles congruent? Looking at this, we said ST, VU, and UZ. So UZ has 3 marks in it, right? VU has 3 marks in it, right? So shouldn't this one have 3 marks in it? Makes sense?
Yeah.
Looking down here, TU, VS, and SY. Okay, SY has 1 mark in it. VS has 1 mark in it, so TU needs to have 1 mark in it. And then eventually, by the same kind of process, you'll find out that that one has to have 2 marks in it. And then every one of those triangles has a side that has 1 mark in it. And then every triangle has a side that has 2 marks in it. And then every triangle has a side that has 3 marks in it. So those triangles are all congruent by what property? Or what property?
Side.
Yep. Side. So UTS by side. And
I guess we're right.
yeah.
Yeah.
What's that?
I said we're right.
Correct.
Yeah.
A little bit of a different proof in regards to, so far we haven't seen those kind of extended equality statements where we have 3 things equal to one another. We haven't seen that you use a transit property kind of in that form in a while. You would have seen substitution, thought substitution. That would have been fine. If you're on the in-course exam and you had to write out the proof by yourself and you wrote substitution, they're going to give you points for that. That's fine. That's how you would approach that question. Try not to. Hurts my eyes. Any others you guys want to talk about? Did we feel okay with this one?
No. I had no idea what I was doing.
You want to do this one?
Yeah.
Okay. All right, so the coordinates of the vertices of the triangle shown. E is 1, 3, F is 7, 9, G is 5, -3. Use the triangles to answer parts A through C. I'm going to just real quick write over here what my points are. 1, 3. I just do a lot better when I stack my points. G is at 5, -3. All right. So it says find the coordinates of H, which is the midpoint of EG, right? And the coordinates of J, which are going to be the midpoint of FG. So, if I'm going to find H, the midpoint of E and G, okay, so I'm going to add E and G's x coordinates together, so I get 6, and then divide by 2, and I get 3, right? Okay, so the x coordinate of my midpoint should be 3, and then the y coordinate of my midpoint, add your y's together, so it gives you 0, divide by 2 gives you 0, right? So 3, 0. Now, my suggestion to you, before you hit enter, before you check the answer, graph it real quick, okay? If I go to 3, 0, Right there where my cursor is. Does that look like that's in the middle of E and G? Yeah, it looks like a midpoint, so I'm probably right. Okay, now I'll find J, which is the midpoint of F to G. Okay, so F to G, I'm going to take these X values and add them together. So it gives me 12. Divide that by 2 and you get 6, right? Okay, so 6, comma, and then add these together. Gives you 6. Divide by 2 gives you 3. Again, before I hit enter, I'm going to graph 6, comma 3. It's about where my cursor is. And that looks like it's between F and G, halfway in between. Check my answer. Good to go. Next part says, show that H, J, and EF, HJ and EF are parallel. Okay? So how do I show that things are parallel? Slopes. Okay? So I'm going to write over here J, which was 6, comma 3, and we'll write H, which was 3, 0. Okay? Now I'm going to find the slope then of those two lines, HJ. So slope of HJ. Remember, it's Y2 minus Y1. So I'm going to find H and J, and we'll subtract their Y values. So 3 minus 0 gives me 3. And then 6 minus 3 gives me 3, right? Okay. So it gives me 1. And if we were to look at these midpoints and look at the segment that I'm actually creating right there, it's that segment. And does it have a positive slope? Is it moving from left to right? Is it going up? Yeah, so a positive slope is makes sense there. I'm going to then do the same thing for EF. Okay, so slope of EF, which again is this line right here. So subtract the y's. 3 minus 9 gives me negative 6. And then 1 minus 7 gives me negative 6 as well. And that gives me 1 again. So when those two slopes are the same, what's it tell you about those two lines? Careful. Parallel. Parallel. Okay. So choosing the option here says the segments HJ and EF are parallel because they both have the same slope of 1. Okay. Next part says show that HJ is half of EF. It says select the correct choice below and fill in the answer boxes to complete your choice. So we're going to find, when it says that, never does it say the word distance, does it? No, but the lack of the symbol above HJ tells you distance HJ is equal to half distance EF. Okay? So we're going to use a distance formula here with those two segments. Okay, so I'm going to find HJ first. So distance of H to J. Remember, that is the change in your x values squared. So when I take these two x values and I subtract them, I get 3, right? Square it, you get 9. Then add to that the difference in your y values squared. So it gives me 9. Okay, so it gives me radical 18, right? Okay. Got to talk about that in a minute, how we can simplify that maybe a couple different ways. But now I want to find EF. So distance of EF. So I'm going to look at these x values and subtract them. Gives me 6. Square it and get 36. Add to that then your y's subtracted. Gives me 6 again. Square it gives me 36. So it gives me a radical 72. Okay. Now, if you were to type that in, I believe it tells you that's wrong. Because that doesn't show, in that format, it does not show that EF and HG compare to one another in regards to being half of one another. Does that make sense? What we want to do is we want to simplify. Okay, so when I simplify these things, okay, a couple approaches here. When you see 18, breaks down to 9 and 2, right? So radical 9 times radical 2, right? Square root of 9 is 3. Square root of 2 is just square root of 2, right? That's one way of doing it, okay? When I see radical 72, okay, one of my techniques that I use, and I've shown you this before, is if I want to simplify a radical, I only need to check perfect squares that are less than half of the number that's underneath the radical. So that's 72. I only need to check the perfect squares that are less than half of that. What is half of 72? 36, right? So what, now we're thinking perfect squares that are less than or equal to 36. That will divide 72. Doesn't 36 do that? How many times is 36 going to 72? Twice, right? Okay, so 72 becomes the same thing as radical 36 times radical 2, but radical 36 is the same as 6, right? So we get 6 radical 2. Does that then show you that those two things are half of one another? HJ. HJ is half of EF. Another way of doing this, and it doesn't happen every single time, but in this case, is 9 plus 9 the same thing as 9 times 2? And does that give me radical 9 times radical 2? And that will give me 3 radical 2, right? Same thing here. Radical 36 times 2. And that gives me radical 6 times radical, radical 36, which is 6, times in radical 2. Does that kind of make sense? Okay, when you see these two numbers being the same when you do the distance, that approach will always work. So now in EF, or in option A, we want to say that they're equal. So EF is 6 radical 2, and this then is 3 radical 2. And we're done. Okay? So that is building us again using this coordinate geometry to get to a stage in the next couple chapters where that is all we're going to do. Okay? We're going to eventually start talking about finding properties about parallelograms, quadrilaterals, trapezoids, that kind of stuff, and strictly working with coordinate geometry. Okay? So we're periodically kind of building those skills throughout these sections to be able to do that. Okay? So hopefully we're kind of getting better at slope, getting better at distance formula,